So now let's consider a problem in which we have a car driving along a road. So we have a car, and the car accelerates at constant acceleration. So the acceleration is constant and is 2.75 meter per second squared, and it does this for 6.41 seconds. Okay, then the car drives at constant speed. And it drives at constant speed for 5.21 seconds. Then the car slows down and stops. Constant acceleration again, deceleration, so it's slowing down. So it stops in 3.27 seconds. So I want to know what's the total distance x that the car went. Okay, so we know we have equations. X equals x naught plus v naught t plus 1/2 a t squared, and v equals v naught plus a t. Okay, so question is now, how do we use those equations? Now the problem is it's moving at constant acceleration here, constant speed here, constant acceleration here. Well, constant speed means constant acceleration also. It means in here the acceleration is 0. So it's constantly 0 when it's going at constant speed. So that means that we have 3 different realms of constant acceleration. So we can call it parts A, parts B, and parts C. So all we're going to do is add up all the different parts. Now, there's 2 and 3 different ways of solving the problem. You could add up all the individual parts. You could find out how far it goes here, how far it goes here, how far it goes here, and add up. Or you can find out how far it goes here, start from there, and find out how much additional it goes, add on, find out how additional it goes, add on. And so there's more than one way of solving this problem. Okay. Now, students often ask me which is the best way of solving the problem. And the answer is whichever way makes sense to you. There's more than one way of solving the problem. What matters is getting the right answer at the end, not the way you got there. And so there's multiple ways of doing this. I do not grade you saying you have to do it one particular way. I'm smart enough that I can figure it out multiple ways, and I'll let you do it in whichever method works best for you. Okay, so let's do part A first. So part A, the car was accelerating here at constant acceleration. Okay, so I said the acceleration was 2.75 meters per second, and it went for 6.41 seconds. Okay, so we know that x equals x naught plus v naught t plus 1/2 a t squared. If we put our origin right here where we start, x naught is 0, v naught is 0, so the distance traveled is simply 1/2 a t squared. So that'll be 1/2 2.75 meter per second squared times 6.41 seconds squared. So the distance traveled turns out to be 56.5 meters. You might ask, how fast is it going at the end of that time? Okay, so write down, there's where it is at the end of that first one. So how fast is it going at the end? Here's on part A, how fast is it going at the end? Well, v equals v naught plus at. Okay, so v naught is 0, so this is just going to be equal to 2.75 meters per second times 6.41 seconds. So the velocity at the end of part A is going to be 17.6 meters per second. Okay, now 17.6 meters per second. See, question. Why did I ask that? Well, because I'm going to use that next. For part B, So it's going at constant speed. And it goes at constant speed for 5.21 seconds. So 5.21 seconds, constant speed. So how far did it go? Well, you need to know what the constant speed is. Well, we know the constant speed. The constant speed is the speed at the end of part A. So that's going to be 17.6 meters per second. Okay, so now it's going to be going at that constant speed. And as it's going at that constant speed, we know that x equals x naught plus v naught t plus 1/2 at squared. Now what I've done is I've set my timer at the beginning of part B. So now v naught is not 0. V naught is going to be the 17.6 meters per second. The acceleration 0. So x naught is going to be how far it was from the original spot, 56.5 meters, plus the v naught, 17.6 meters per second, times 5.21 seconds. So that's going to be equal to a total of 148.2 meters. Now you could have just done this part right there. Just that part right there was 91.7 meters. And so you could have done just that and kept track of that and added up all the different parts later if you wanted to. I'm lazy. I don't want to do all that. I'm going to keep track of this as it's going. Okay, so the x naught is how far we are from the origin, the original origin of the problem. Now, part C, it's slowing down. So it's stopping, and it stops in 3.27 seconds. So x is x naught plus v naught t plus 1/2 at squared. So x naught, that's going to be pretty straightforward. X naught is the 148.2 meters. That's how far it was from the origin. V naught is how fast it is at the beginning of part C. So that's going to be 17.6 meters per second. T, we've got that. What's A? So we have to figure out A. Well, we know that V equals V naught plus AT. So the final velocity is 0 because it stopped. So we do algebra here and we find A is minus V naught over T. So A is going to be minus 17.6 meters per second divided by the 3.27 seconds. So A is going to be a negative 5.38 meter per second squared. So now we can plug all that into our equation. So this is now going to be 148.2 meters plus 17.6 meters per second times 3.27 seconds plus 1/2 times the negative 5.38 meter per second squared times the 3.27 seconds squared. And so x is now going to be equal to a grand total of 177 meters. Okay. So great. Well, is there another way of solving the problem? Back here, we said that x was x naught plus v naught t plus 1/2 at squared. What I did to find a was I said that v equals v naught plus at. I found that a was minus v naught over t. I could have plugged that in here and done algebra if I wanted to. So x would have been x naught plus v naught t plus 1/2 minus v naught t squared. Or in other words, this would have been equal to x naught plus V naught T over 2. If I plug in the numbers that I had, so I plug in the numbers, so that would be 148.2 meters plus the 1/2 or the V naught T over 2. So that would be 17.6 meters per second times 3.27 seconds. Divide that by 2, and the answer comes out to be 177 meters. Same answer as before. Well, of course it's the same answer as before because it's exactly the same problem as before. And so this is just another way of getting that same answer. Okay. As I've said many times, there's more than one way of solving these problems. What I'm after is the final answer. The final answer is the car, after all 3 steps, went 177 meters.